And finally, dear grade 11 students, we reached the last training exercise, the third one, and we have to solve the system. That's 27 minus x cubed greater or equal to 0, and 3x squared plus 6x plus 3 over 2 minus 3x into x squared plus x minus 2 less than 0. Now the first one, let's call it 1 here, and here is 2 for the second one in order to put it in the table. Now according to the first inequality, 27 minus x cubed can be factorized as 3 minus x into 9 plus 3x plus x squared. As you know, 27 is 3 cubed, and there is a property that says that a cubed, there is an identity that says that a cubed minus b cubed is equal to a minus b into a squared plus ab plus b squared. So we applied this identity on 27 minus x cubed because 27 is 3 cubed. Then we get 3 minus x into 9 plus their product 3 times x plus the squaring of the other one, and 9 here is the squaring of 3. Now the roots for this one are or is only 3. So the root for 3 minus x is 3. But for 9 plus 3x plus x squared, let's see what we have. We usually know that it has no roots, but let's make sure. So what are the roots of 9 plus 3x plus x squared? Here a is 1. A is the coefficient of x squared, and b is the coefficient of x, which is 3, and c, the constant, is 9. So let's see what we are going to get. There is I here. That means that this has no real solutions, and delta is negative as well. Because delta is negative, then we have to take the sign of a, which is positive. So all of this factor is positive. The sign of this one is positive, thus we just care about the sign of the linear 3 minus x. Now when we put it on the table, we can put this or we cannot, no problem. So 9 plus 3x plus x squared has no roots, just positives, positive signs, while 3 minus x, the root of it is 3. And as you know, before, because it's linear, before the root, we put the opposite sign of x. As you see here, it is minus, so before the root, we put the opposite sign of x, and after the root we put the same sign of x, which is minus. Okay, so here we have plus and minus, multiplying them we get plus and minus, and this is the root again, 0 at the root. Now we need it greater or equal to 0, which means we need the positive part. As we do every time, we need the positive part, which is here, the positive region between minus infinity and 3, and we close it at 3. We close the interval at 3 because we have or equal, thus the root is included. This is for solution 1, and let's see what we have for solution 2. According to this second one, we have to care about the numerator and the denominator. Now according to the numerator, I guess there is a double root. If you take 3 as a common, you are going to get an identity inside, and let's make sure. Okay, the coefficient of a, the coefficient of x squared is 3. For b it is 6, and for c it's 3 again. Then look, we have x equals minus 1. If we press another equal, we have the same value. Okay, so minus 1 is a double root for the numerator. Now what about the denominator? We have two factors. The root of the linear factor, 2 minus 3x, is exactly 2 over 3 as written here. So it's clear how to calculate the root for this one. And according to this one, again we use the calculator. The coefficient of x squared, which is a, is 1. For b it is 1, and for c it is minus 2. Thus we have one of the roots is 1 and the other is minus 2. Or we can use the idea of a plus b plus c equals 0. Then definitely one of the roots is 1 and the other is c over a, which is minus 2 over 1, which is minus 2. Of course, the calculator helps us very much. Now we put the numerator and the denominator separated on the table. We put the roots, we spread them in the increasing order. So we start with minus 2, then with minus 1, then with 2 over 3, and then with 1. And here are the infinities. So the numerator is here. We apply the idea of same sign of a. Because we have a double root, then definitely delta equals 0. Thus, when delta equals 0, we have to take the same sign of a, which is here plus. That's why we put pluses all over this here. And the root is minus 1, so we put a 0 on minus 1. According to 2 minus 3x, the root of it is 2 over 3, so we put dashes because it's in the denominator. Now, before the root, because it's linear, x is of power 1, before the root, we use the same, we put the opposite sign of x, and here x is multiplied by minus 3, then its sign is minus. So before its root, we put pluses, and after the root, we put the same sign, which is minus. Now, according to that one, we use the idea of SOS. Okay, same, opposite, same. The roots are minus 2 and 1. So same, as you see here, the sign of a is plus because there are two real distinct roots, then delta is positive, then we use the idea of same, opposite. So same, opposite, same. Now multiplying them, we get here plus, here minus, here plus, and here minus. We need to find the solution according to that less than 0, then we care about the negative regions, the region where there is a negative sign. So less than 0 means a negative sign, so we care about that region and that region and that region. So we have 3 regions, and thus, as you see here, S2, solution 2 equals the opened interval minus 2 and opened at minus 1, though we don't have dashes, but there is no or equal here, union minus 1 again till 2 over 3, union from 1 till plus infinity, and all of the intervals are open because we don't have or equal. Now finally, we have to maintain the solution, which is the intersection of S1 and S2 using the number line as we do every time. Now using the number line, the blue ones represent solution 1. It's from minus infinity to 3. Of course, we arrange the numbers in the increasing order as we do every time. Minus 2, minus 1, 2 over 3, 1, and 3. We care about the numbers appearing in the solutions. Now, according to solution 1, it's from minus infinity to 3, closed at 3. That's why it's discrete here. And according to solution 2, we have it between minus 2 and minus 1, then between minus 1 and 2 over 3, then between 1 and plus infinity. So the intersection part is between minus 2 and 2 over 3 opened, as you see, between minus 2 and minus 1, and between minus 1 and 2 over 3. We cannot put it directly from minus 2 to 2 over 3 because at 1 it is still opened. We don't need minus 1, so we cannot write from minus 2 to 2 over 3. We write it from minus 2 to minus 1, union from minus 1 to 2 over 3, and union from 1 to 3, and the closed at 3. Hope you are now better in solving systems of inequalities. Hope I can benefit you from these videos, and meet in another videos inshallah about solving special cases of systems, and another videos about limits inshallah.